Now moving ahead, now we are done with Newton's first law. We know law of inertia. We also know momentum, Newton's second law. Moving ahead towards the third law, which was given by Newton. Very famous one, very simple to learn, and I hope everybody must be knowing it. And the statement says that action and reaction are equal and opposite, but acts on two different objects. Okay, so I'm quite sure that most of you must be remembering this statement till here, that action and reaction are equal and opposite, but this is the most important part of this statement, but acts on two different objects. Here I'd like to mention one more very important thing. You must have read in certain books also, but this thing is very important, that Newton's first law, if you are talking about, in which it was said that an object at rest will remain at rest, an object in motion will remain in motion unless some external force is applied. That law was only talking about one object. Okay, एक ऑब्जेक्ट रेस्ट पे है तो रेस्ट पे रहेगा, एक ऑब्जेक्ट मूव कर रहा है तो मूव करता रहेगा, फॉर ओनली वन ऑब्जेक्ट. नाउ व्हेन वी टॉक्ड अबाउट न्यूटन्स सेकंड लॉ, there also we had seen that external unbalanced force applied is directly proportional to rate of change of momentum. There also, if you remember, we had talked about an object which had certain mass m, initial velocity, after certain time final velocity, but we only had, point to remember is we only had taken one object. That is the reason the mass was constant over there. So there also we talked about only one object. So Newton's first law, Newton's second law, both were talking about one object, but this Newton's third law is talking about two objects. Okay, now action and reaction are equal and opposite and are acting on two different objects. So if there are two objects, both are coming towards each other, after certain time they will collide, right? So this is action, this is reaction, and you can see action and reaction are equal, opposite. Now suppose this is 10 Newton, this is also 10 Newton, and acting on two different objects. So there are two different objects. This is object 1, this is object 2. So this is a very important thing to remember, that Newton's third law is talking about two different objects. Okay, now if we are talking about two different objects, how are we going to talk in numeric terms? What is going to be the formula for Newton's third law? The formula for force, here you have to remember, children, when you will be solving the numericals, in certain questions you will be using the formula for force is F equals to ma. Somewhere you will be using it F equals to P2 minus P1 by T. So it depends on the situation. So formula for force for Newton's third law also will remain either F equals to ma or P2 minus P1 by T. The formula is not going to change. But the situation here is saying that, suppose this is an object A and this is an object B. Okay, this object A is applying force from here on object B, so I can write it as FAB. Similarly, this force, this object B is also applying certain force, so I can write it as FBA. But here, because the direction is opposite, one is moving this side, one is moving from this side, so I can have a negative sign over here just to say that the direction is opposite. Negative sign here, and in physics, if you talk about, you must have seen in displacement, you must have seen in retardation also in chapter 1, motion. The negative sign is telling you the direction, from which direction it is coming. If the direction is opposite, you will see a negative sign. So if I am talking about numeric formula for Newton's third law, I can write it as FAB equals to minus of FBA. Now here, whatever formula you want to put in, it depends upon what is given in the numerical. You can use FAB equals to minus FBA. What you simply have to remember this, you have to put one negative sign when one of the force. Okay, now as we know Newton's third law now, that action and reaction are equal and opposite and are acting on two different objects. Let us talk about a few examples. Okay, again from your real life, from your daily life examples we are going to talk about. The very common example which is also mentioned in your textbook, and I want you all to please go through the textbook also, read the chapter over there. You will find out certain interesting things, and if there is any problem, you can contact me through MS Teams also. So here we are talking about one of the example which is given in the textbook, and the example says that suppose you have a table and a book is kept on top of it, and there is a book which is kept on top of it. This follows Newton's third law. Now how to explain? It's a very simple thing. Book rakha hai table ke upar. How it is following Newton's third law? How we have to prove it actually? So now because the book has certain weight, and we all know that weight acts in the downward direction, because what is weight? Weight equals to the product of mass into gravity, and gravity always acts in the downward direction. Similarly, these legs of the chair or the table is applying some normal force in the upward direction, okay, and this weight and normal are acting from the opposite direction. So I can write it W equals to minus N according to Newton's third law, and the value of both these are same. So what will happen? This book will remain at its own position because forces are cancelling out each other, okay, they are equal. So this book will remain over there. So how can you explain that the weight of the book is acting in the downward direction, action, normal force is acting on the upward direction, reaction, equal, both are equal, and opposite, and this negative sign is giving you the opposite direction. Okay, now another example again from your real life, from your daily life, is swimming. Now if you have to prove that swimming is also following Newton's third law, how can we prove it? When a person swims, what a person does actually, the person pushes the water in the backward direction, and in turn what happens? The person moves ahead. Okay, again Newton's third law, action and reaction are equal and opposite. See, the directions are opposite over here. Okay, now one more example, again a very common example, rocket. Okay, you must have seen that the rocket is placed somewhat like this. Okay, this is a rocket. You have to just assume that this is a rocket. Rocket is always placed in this position, and the moment the fuel starts to burn, the fuel of a rocket is also known as propellant. It is known as propellant, and propellant actually is a mixture of diesel, petrol, and certain gases. Okay, so what we see, the moment fuel starts to burn, you must have seen the fire, the burning flame coming down. The moment the flame starts to come down, with the same force, the rocket starts to move upward in the opposite direction. So action and reaction are equal, and they are in the opposite direction. So there are n number of things that we can talk about Newton's third law. Okay, one example, one question I'd like to basically ask, and because here I am only talking, so I'll answer that question also, but you have to understand what am I saying. Now suppose you are in a certain spaceship, okay, and by any chance, again it's an imaginary thing, you simply have to assume, okay, there is a spaceship, you were inside it, and by any case you just came out of it. Okay, now you don't say that the person's body will burst out. I'm giving you an imaginary situation over here. Now this is you have come out of the spaceship, no rope is there, nothing is there, but you have to go inside it. Okay, by accident you came out, but you again want to go inside the spaceship. There is no rope attached to you, nothing is there. How will you enter inside the spaceship? Okay, question is this. Now in this situation, you have to follow Newton's third law. Okay, please think about it. I am going to answer this question in the next video of mine, but this is a question for you. There is a spaceship, by accident you came out of the spaceship, there is no rope attached to it, nothing is there, you are simply flying in the space, but you want to come inside the spaceship. What are you going to do, okay, to come inside? But I am giving you a hint, you have to use Newton's third law over here. Thank you.